Right. So today I will talk about projectile motion. So if you want to define what is a projectile, there is any object thrown in air with some initial velocity at an angle less than 90 degree and allowed to move under the action of gravity is known as a projectile. I repeat, if an object is thrown in air with some initial velocity at an angle less than 90 degree, then allowed to move under the action of gravity is known as a projectile. And the path followed by the projectile is called as a trajectory. Trajectory is the path followed by the projectile. So, when you throw an object, it has two components of velocity. So if I say u is the initial velocity of the projectile, then we got a horizontal component which is known as u cos theta, and a vertical component which is known as u sin theta. And throughout the projectile motion, the horizontal component does not change. It remains a constant. Whereas the vertical component keeps on changing. So it always changes in vertical direction. I mean, it increases or decreases. So there are two types of projectile motion. One is called horizontal projectiles or horizontal projection. The one like an object is just pushed down from a building. So it follows a path like this. So this is called horizontal projection. And other one is called as angular projection or oblique projection. Angular projection, or otherwise called as oblique projection. The one which we talked earlier, like if we take time along x-axis, displacement along y-axis. So we throw an object with an initial velocity u at angle theta, which is less than 90 degree. So it moves till a height, then it falls under the gravity, under the action of gravity. And you call this as a projectile. That's what we defined earlier. And this is about the two types of projectile motion. So let us discuss about the horizontal projection in detail. If we talk about horizontal projection, like consider a tall building. And an object is projected from this point. So it just falls here, right? And it is given an initial velocity u at the point say O. Let the height be h, and you can consider this as the y component, right? And the distance that the projectile hits on the ground from the building's base is taken as the range, the x component, right? Okay. Now, the distance x can be easily calculated by the formula. The horizontal velocity ux is equal to displacement by time of flight. Therefore, I can say x is equal to ux into t. So this gives us the horizontal distance. Now, how about the vertical distance? When I talk about the vertical distance, I'm going to use the equation of motion. S is equal to ut plus half a t square. Now S becomes y. The initial velocity along the vertical direction is 0 at the highest point. So I can say uy is initially 0. So we'll get half accelerations along the gravity. So it is plus g t square. So we get y is equal to half g t square. This is about the vertical displacement. Now substitute for the t from this equation. So I get y is equal to half g x by ux the whole square. So y is equal to half g x square by ux square. So you get an equation y is equal to g by 2ux square x square. So this is of a general format, y is equal to kx square, which represents the equation of a parabola. Where k is equal to g by 2u x square, x component. So the trajectory of a horizontal projection is a parabola. So the equation y is equal to kx square is a standard equation of a parabola. So the path that is from O to say a point A is a parabolic path. So this is about the trajectory of this horizontal projection. Now, what is the time taken to reach from the building's top to the bottom? We call it as time of flight. So time of flight, again, we are going to use the same displacement equation. S is equal to ut plus half a t square. So initial velocity along vertical direction uy is 0, so that ut term becomes 0. Let me call the S is equal to height, which is equal to half g, the time taken to fly is t square. So t square becomes 2h by g. Therefore, t is equal to root of 2h by g. It's very similar to a free fall condition we have learned in previous lesson. So if you drop an object from a height, the object falls like this. Okay, it travels a distance height. Or if you give a horizontal projection, the object makes a parabolic path and falls like this. In both the cases, the time taken remains a constant. And if you see clearly, the distance traveled in n seconds, somewhere if you divide them, that also remains same. So the distance traveled, vertical distance covered by the two particles in same equal intervals of time is going to be same. I repeat again, the distance, vertical distance covered by the two particles is same in equal intervals, right? So this will give you the time taken. And if you want to find the range of the particle, range of the projectile, range is x, which is ux into time of flight t. So x becomes ux into root of 2h by g. X for the horizontal component. So it's very clear that the range is directly proportional to the initial velocity and inversely proportional to the acceleration due to root upon acceleration due to gravity. Right? So at any point in this projection, if we were asked to find the resultant velocity, set any point, and just go on with our page, right? So this was the image which we already have seen this. This is the ground, and the projectile follows a trajectory like this, right? So this was the point O, and let this point be somewhere A, and let us consider some point here, a point P, where the horizontal velocity is ux, not ux, we will call it as vx, since u was the initial one, and the vertical velocity be vy. So we need to find the resultant velocity, making an angle beta with the horizontal at a time interval of t, right? So it's going to be simple again. And we know that ux was taken as u, and x will be 0 because the velocity never changes. So to substitute vx is equal to ux plus at, this term becomes 0. So I can say vx is equal to u. Now let's find for vy. Again, in the same case, uy will be 0 and a becomes plus g. Substitute in the above equation. Vy is equal to uy plus at. Again, vy becomes gt. Vx and vy are perpendicular. So to find the resultant, right? So v becomes root of u square plus g square t square. So this gives you the resultant velocity. And you can express this in a vector form as v vector is equal to ui vector plus gt j. The vector form of the resultant velocity. So what will be the velocity when the projectile hits the ground? Velocity at the point A. So again, you can find this easily by writing u square plus g into t. That gives you 2gh. Since you know that t is equal to root of 2h by g, and we need to find gt, that is equal to root of 2h g square by g, where the g gets cancelled. So you get the value 2gh. So this is the data that gives you the velocity with which the projectile hits the ground. So this is about your horizontal projection. So we have discussed what is the projectile motion and what are the two important things to be remembered. We talk about projectile motion, you talk about the two components of the velocity, and the one, the horizontal, doesn't change, it remains a constant, and the one which is vertical, it keeps on changing with respect to time. And if we talk about horizontal projection, we have found the range, that is x, the horizontal distance, the height y, the vertical distance, and substituting the value of t from x, you get to know that the path of the projectile is a parabola. We have found time of flight and the range of the projectile and the dependency of the range of projectile to the initial velocity and the acceleration due to gravity. Finally, we spoke about the average velocity or the resultant velocity of the projectile at any point, then the velocity with which the projectile hits the ground when it is projected with some initial velocity u.